Suppose you have two vectors, two position vectors. You're given the question. You have vector OA is, let me see now, let's say it is 2, 3, and vector OB is 5, 6. All right. Then what is vector AB? Right? You can write vector AB in terms of A and B, and you can also write a column matrix to represent it. So in that case, let's do a little sketch. It's an X and Y axis. I don't think I'll have to worry too much about the numbers in the negative, so I won't leave much space for the negative numbers. I don't see any, I didn't put any negative number here, so I leave much space for the positive values. 0, I have 0 here, so -1, but I need to have more in positive than negative numbers. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I know that the X value goes as far as 5 and the Y value goes as far as 6. So I don't think I'll run out of space while working with this. Now OA. Let's represent OA. A is at 2, 3. Remember, when you represent a matrix using a vector using the column matrix, it is in the form X up here and Y down here. So the 2 is telling me where, the 2 is telling me where along the x-axis, along the horizontal axis, how far across I should go. The 3 is telling me where along the y-axis I should point. That means how far up or down I should go to identify my 3. So 2 is here and 3 along X, and 3 is here along Y. And I think that the 2 and 3, without drawing, without sketching any construction lines per se, I believe they're going to meet right here. So OA is this vector. So A is right here. Alright. OB 5 along X. So I identify 5 here. 6 along Y. I see 6 up there. So my estimation shows that this is above 5 and beside 6. So I think going to be right there. Alright. So this is OC. But these two lines are kind of too close, you know. I don't like how close they are. I had used 5, 6. Let's use 6, 5 instead. Let's change these numbers, because I don't like how near these things are. Alright, let me get rid of that. Use 6, 5 instead. So let's say OB is 6, 5. So 6 along X and 5, 6 along the X, 5 along the Y. So looking at a point above the 6 and beside the 5, I estimate it's here. Alright, so yeah, 6, 5. I think this is a little better. The two vectors are not so close. Alright, there's a little space between them. So OA is 2, 3. Alright, now 2, 3. I didn't put in my construction lines, but I can put them in now. Don't really want to crowd this thing too much, too many dots and lines and diagrams. OB is above 6 and beside 5. Good. Now what is AB? Let me make sure to put my B here. Now AB is going to be this vector. Let me use red, draw it in red. AB is this vector. Alright, now let's see what happens if I want to write AB, the vector AB, in the form OA and OB using letters. I have to now use my imagination. AB is the resultant of adding two vectors, but what are the vectors? Remember, when you add two vectors, the arrows must follow around the triangle that you form. Now the arrow and the resultant must oppose the arrow on the two triangles you're adding. If you go along OB and turn the corner, what you find is that the arrow on AB is opposing the arrow on OB, which is what it should be. So one of the vector you're adding is OB. Let me redraw OB. Let me redraw it here. This is OB. Alright? The resultant is this. This is A and this is B. Let me maintain the color of my A in black. This is A. As for OA, no, that is another case. Let me draw this line to represent my OA. But the thing is, the arrow was pointing up. In order for OA, in order for me to add these vectors, I must turn around the arrow. OA was going up here, but now that the arrow is turned around, I can't call it OA again. It's AO. Now when you change the direction, when you turn around the arrow on a vector like OA, I can call it AO, or I can call it negative OA. So in this case, since I had to turn around the arrow on vector OA, I call it negative OA. It's negative OA plus the arrow on OB remain the same, so it's OB. So AB is negative OA plus OB. I had to use negative OA because I had to turn around the arrow on OA, because I want OA, I want this vector and this vector to follow each other while both of them are being opposed by the arrow and the resultant. Alright, now I also want AB to be represented as a column vector. How do I do that? Well, what I'll have to do is look at this and say, if I should go from A to B to make AB, I have to say, what are the horizontal and vertical components of AB? In other words, moving from A to B, how far horizontally do I move, and in which direction? Since I'm going from A to B, the horizontal line must go to the right, so it's a positive. So I have my column vector, it's positive, and it was A was above 2 and B above 6. So how far do I move from left to right? I move 1 place, 2 places to 4, 3 places to 5, 4 places going to 6. So I cover 4 places, so this is a 4. Good. So the x value is positive 4. Now horizontally, if I go from A to B and I form a triangle, when I was beside A, at A I would have been beside 3, and at B I'm beside 5. So how far up would you have to go move to go from being beside A to being beside B? To go from 3 to 4, that's 1 place, then from 4 to 5, that's 1 more place. So I move 2 places. You see that? 2 places up. Alright. Now, let's see if there's any connection between this and this. Let's rewrite AB. It's negative OA. OA was 2, 3. So it's negative 2, 3 plus OB. I have my OB here, 6, 5. Now what happens? You see this negative? It's going to change the 2 to negative and the 3 to negative. So it's negative 2, negative 3 plus 6, 5. Let's continue here. Now when I put these numbers together, it's going to be negative 2 plus 6 to give me my new x. My new y will be negative 3 plus 5. Negative 2 plus 6 is negative 2 plus 6 is 4. Negative 3 plus 5 is 2. So you see here, AB is 4, 2. And you notice it's the same result that we got from looking at the sketch of the vectors. Alright? So AB is 4, 2. 4, 2 means 4 to the right, moving from A to B. You could go straight across, straight along the vector to B, but you could go 4 to the right and then 2 up, and you end up at the same place. You end up at B. So when adding 2 vectors, I would highly recommend that you do something like this. You do a little sketch as part of your rough work. You do a sketch so you can see what you're doing, and then you draw the vectors, and that will tell you whether you should change the direction of the arrow on any of them. and it enables you to actually see what you're doing. It gives you a visual representation of what you're doing when you're adding vectors. All right, so I think that was quite a bit of material to cover in adding vectors. I'll see you later. We're going to look at some examples from some CSEC past papers.